Hello, everyone. Greetings of the day. Dear authors and invited guests, welcome to the technical session 9D. Myself, Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development ICT4SD 2025 Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be provided 20 minutes for the presentations and 2 minutes for questions and answers. On the ninth minute, I will be raising a gentle reminder. There is another request to all our participants that you all stay connected with us till the closing remarks. If you have any queries or any requests, you can write it to me in the chat box given down below. Before we start our session today, I would like to introduce you all to our session chair for this session, Dr. Aneri Kilol Pandya. Dr. Anindi Kilor Pandya is an assistant professor at CPIT, Charusat University, Gujarat, India. She completed her BE in 2008 and ME in 2010 from Maharaja Sayaji Rao University of Baroda and earned her PhD from Charusat University in 2022. With over 13 years of academic experience, Dr. Pandya has contributed significantly to research publishing 20 papers in journals and conferences. We welcome you to the meeting, ma'am. So I'll just start with our first presenter for this session. Our first presenter for this session is Sharvani V. Nagor, a comprehensive framework for LiDAR camera calibration and temporal synchronization using target-based method. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, I'm here. Can I start?
Yes, please.
Good afternoon, everyone. I am Sharvani from Kelly Technological University, Hubballi. Our project is based on the camera LiDAR calibration, and it's named as a comprehensive framework for LiDAR camera calibration and temporal synchronization using a target-based method. We all know that autonomous vehicles are transforming transportation by making travel safer and more efficient through advanced perception and intelligent decision making. The one of the technology for which supports this is like known as vehicle to everything communication, where the technologies allows like communication with the other vehicles, infrastructure, even pedestrians, and enabling real-time data exchanges. To pursue these accurately autonomous vehicles rely on multiple sensors. We know that camera offers that 2D information like texture, object patterns, and scene context, which helps in recognizing and understanding objects. However, their performance can drop during the raining, bad light, poor lighting, weather, and other when other objects can blocked. Then we can come through the other lidar sensors known as lidar, which improves the perception by generating high precision 3D spatial data in which also calculate the depth and distance, and it works well even in the low light conditions. So we can combine these two lidar and camera sensors to get the proper data for the driver or the car to drive safe for the movement. Integration of multiple sensors is essential for real-time environmental awareness and is a foundation to the progression toward for fully autonomous driving systems. This is like introduction for our projects. Then objectives for our projects is to develop a unified framework which accurate spatial and temporal alignment between camera and lidar, and calibrating intrinsic and extrinsic parameters from the camera and lidar sensors, implement temporal synchronization and projection. We have used two sensors known as camera and lidar. This is the setup of the camera and lidar in our lab environment. The data specifications for the camera and lidar is like camera is used as Logitech C270 webcam. The frame rate of the camera is 20 fps, where frame rate is known as specified sampling rate of the video. The format is we have captured the camera in two formats, .mp4 and .png. Whereas the lidar we have used is the Velodyne VLP16, and the scan rate is 10 hertz, where it scans one frame, 10 frames per 1 minute. And the format which we have captured the data from the lidar is .pcap files. This is the methodology which we have used to carry on the project. Specifically, we have used camera and lidar to capture the data set, where cameras, as already I told, camera captures the images at the rate of fps 20, and lidar is at the rate of 10. We have collected camera in two formats, .mp4 and .png, where .png format of the camera used only for the calibration method, which we'll discuss further, and lidar captures the data in the form of pcap format without explicit timestamps. The pre-processing is like converting the .mp4 format of the camera to .png format, which is used for the projection or matching the frames, and the lidar dataset is converted to pcd format, which is very which has the structured data set when compared to the .pcap, where .pcap file is raw data, and pcd format for it is considered structured data, and it is very helpful during the coding. Next, we will timestamp the frames captured from the camera and frames captured from the lidar, where timestamping is done with the help of the reference of Windows clock. We have also added a offset of 1.25 seconds to the lidar camera timestamps, which there is a time, because there is a timestamp between the clock drift between the starting of the sensors to capture the data. Next, we use the synchronization for the lidar and camera frames, as known as method nearest neighboring method, where we used nearest neighboring method, where each lidar frame is matched with the camera frame that has the closest timestamp. As we mentioned that .png data of camera and .pcd data is used to calibration, where calibration is used to align the coordinate of both sensors, where calibration involves two parameters, intrinsic and extrinsic intrinsic and extrinsic parameters, where intrinsic parameters involves internal parameters of the camera's focal length, optical centers, and distortion coefficients of the lens, and extrinsic involves the rotational and translation matrix of the spatial alignment. Using these intrinsic and extrinsic calibration values obtained from MATLAB, the 3D lidar points were projected onto the 2D plane of the camera frames. This is the results which we have done. The intrinsic calibration or the calibration calculation is performed by the MATLAB's app known as lidar camera calibration app, where we have used a target called as a checkerboard, where it is a 7x6 checkerboard. In the firstly camera calibration, there is a detection of the calibration, and we have got the intrinsic parameters, focal length, and the optic centers, as we can see in the matrix, and distortion coefficients of the lens, which is very less during our project. We can see in the distortion coefficients matrix, and extensive calibration projection matrix, where we can see in the first image that the lidar points can be projected on the camera frames, which is nearly accurate to the checker box. And in the right side of the images, we can see that the lidar framework, where we can see that, and the rotational and translation matrix values can be obtained from the lidar camera's calibration app, which is used in the MATLAB. So these are the values which we have obtained while performing the lidar camera calibrations. This is the data which we have collected from the camera data and the lidar data. The camera data is from the .mp4, which is converted to PNG. We can see that the raw data collected from the camera and raw data collected from the lidar. These are the timestamps of the individual frames of camera and lidar. The We can see that the timestamps are nearly matched to the camera timestamps. Then further, we have projected the lidar point clouds to the camera. This is the implementation of time synchronization projection verification for the LiDAR and camera data, which highlights the importance of the sensor fusion in autonomous vehicle system. By employing these nearest neighbor matching approach, we have achieved efficient and precise time alignment and real-time synchronization. The projection process validated on correct spatial alignment of the LiDAR point clouds onto camera frame. The future work of this project can be used for the object detection, depth estimation, and some of the precise things in the project. Thank you.
Thank you so much for your presentation. Uh, I would like to ask Professor Pandya, ma'am, do we have any questions for ma'am? Okay. Any questions? Okay. Thank you so much for your presentation, ma'am. I would now like to move upon our next presenter.
Thank you.
Thank you so much. Our next presenter is Divyendu Rath, presenting a paper on the title, A Study on the Use of Wearable Sensors to Empower Personalized Healthcare. I request you to kindly take over with your presentation, please.
Hello, good afternoon. Am I audible, madam?
Yes, sir, you're audible.
Thank you. Hello, good afternoon, everyone. First, I would like to thank all the members for giving me this opportunity. Uh, Today, I am going to present on the topic of a study on use of wearable sensors to empower personalized healthcare. Basically, it is a team effort. So the authors are Wendila Biswas, Dr. Urangsu Giri, Dipanita Chakraborty, and myself, Dibendu Roth. So first, I will focus on the wearable sensor. What is basically wearable sensor? Basically, it is a device, and the wearable sensor device such as like fitness tracker. As an example, we can say Fitbit, Apple Watch, Samsung Gear. These are basically used for monitoring the physical parameters of our health. So the advanced healthcare wearable accommodate user to monitor and compare the physiological parameters of our health. In healthcare sector, basically uh, nowadays IoT is linked. That means the two devices are connected to the internet and continuously sending the data and communicating between them and sending the data regarding the healthcare. So these wearable sensor basically benefits to create a proactive healthcare system and which can affect in the personalized healthcare through enable the continuous health tracking. The wearable healthcare device also a positive impact throughout the consumer as well as throughout the society. Now, personalized healthcare. Basically, personalized healthcare means the customize the medical care to individual unique characteristics depending on the genetics, lifestyle, environment, medical history, and even the personal values also. So basically, the aim of or the focus of the personalized healthcare that to prevent, predict, and treat the diseases more effectively, and basically the diagnosis is done very preliminary stage. So we can using the wearable sensor devices, we can take this benefit from that. So yeah, our objective in this study is to study how wearable sensors can engage customers and how much it can influence customers intention to improve to impart personalized healthcare, to study how the benefits of wearable sensor based healthcare devices can avoid the perceived risk of the consumer and how they get empowered with the same with this device. So next, I will go to the next slide, and that is the conceptual background. Basically, in conceptual background study, we are focusing two theorems. First one is technology acceptance model, and second one is behavioral reasoning theory. The technological acceptance model, it is basically there is three main part or three main key point, that is PU or perceived usefulness, second one perceived ease of use, in short form PEU, and technology acceptance, that is TA. And in BRT, that is behavioral reasoning theory, basically there are two aspects. First one is perceived benefit, that is in short form PB, and next one perceived risk, that is PR. So we are trying, we are here, we build or structure a model through using these two theorem, and which is basically linked with empowerment of the consumer. So there is another thing, that is user engagement. The user engagement, basically the process of consumer or group of consumer particular product or services. Basically, the depending on this theorem, that is TAM, or technology acceptance theorem, the technology acceptance theorem, the three aspect basically related with this user engagement. So basically, if the consumer gives satisfied and give some benefits, or trust level towards the company or the device, then user willing to engage with this device. And next one, that is perceived benefit. That means the it is a psychological state, and it is a positive psychological state, which is comes from the satisfaction from after consuming the product. And next is the perceived risk, which is basically a negative state of mind. And there are many kind of risk factor or harmful effects which is comes in consumer mind, like privacy risk, health related risk, financial risk, accuracy risk, the longevity risk of the device, risk of addiction, security risk, safety risk, performance risk, etc. And last, that is the user empowerment. So in the model, we can clearly shows that how the perceived risk, perceived benefit, and the user empowerment all are connected to each other. And there we basically four hypotheses we are prepared. First one is the basically user engagement, which is related with the perceived benefit, and this is positively related. And perceived risk, basically positively with the user engagement. And hypothesis 3, the perceived benefit, which is positively related with the customer empowerment, but the perceived risk, which is negatively related with the customer empowerment. So this is the hypothetical model basically. So in this part, this square part basically comes from the TAM theorem. TAM, that is technological acceptance model. So here, perceived usefulness, perceived ease of use, and technology acceptance, all of three basically increase the user engagement. Basically, uh, these three uh, these three aspect basically motivate the user to engage with the technology. And perceived benefit, that is clearly related with the user engagement positively, and perceived risk also related positively. Why? If the consumer willing to or engage with the device, then the uh, risk may be occurred, but there will be chances for risk. But if the consumer do not consume, then there is a no chance of risk. So this is positively related. But in user empowerment, if the customer or user he thinks for the benefit, then he engage and he will be empowered, his knowledge will be empowered, his skill will be empowered, the time, money, financial, everything, every kind of in every aspect the consumer will be empowered. But if the consumer thoughts about the perceived risk, then the consumer should not be empowered from the wearable sensor device. So this is negatively rated. Next, basically, we are using the convenience sampling method, and for qualitative analysis, we are using in vivo software. So here clearly we found the 4 points. First one is user engagement, personal PV for personal perceived benefit, personal risks, and UM. So that's why the four hypotheses prepared, and it is clearly seen in the in vivo software. So qualitative, which basically analyzes the qualitative part. In quantitative analysis, basically our study, the period of our study was November 2024 to January 2025, and we are taking 382 Indian participants, but the 361 participants, they delivered their responses, and this is our demographic profile. Basically, we focus around the age of 30 to 60. Maximum responded from this category, and their education qualification is basically from every sector. There are higher educated and also undergraduate level also.
Excuse me, sir. I'm really sorry to interrupt you. However, we have exceeded our 9-minute mark. So I request you to kindly conclude as soon
Okay,
as
okay.
possible.
I'll conclude in this. And last, that is the measurement model. There is we do the reliability test and validity test, and they are clearly shows that the result shows the consistency and the accuracy of the data, and and next, the hypothesis is strongly accepted in this structural model. We can see the all the hypotheses strongly accepted, and in the findings basically we found the relation between all hypotheses, and it is clearly shown that the perceived risks and user engagement, user empowerment, basically they are positive related, and perceived risks with the empowerment is negative related. So there is an implication for the healthcare manufacturer and marketer, and there is also managerial and theoretical implications also. The device features should be equipped the real-time health monitoring as well as the assurance of the data privacy included. And these are the conclusion of our study. Basically, we take the result that the customer is empowered from this wearable sensor device, and create a proactive or a very efficient healthcare system. And basically these are our limitation. Basically we are doing a convenience sampling method, and our sample size is very less according to the population of our country. So these are, and there is a very future scope, because very in-depth consultation, in-depth responded communication is very necessary for further development. And these are the reference of our study. Okay, thank you, thank you.
Thank you so much, sir, for your presentation.
Okay. Okay. Thank you, sir. And there is one question regarding your presentation. You are facing any privacy challenges which are associated with continuous health monitoring?
Hello.
Hello, sir. My
Can you
voice is
repeat?
audible to you?
Yes, yes, yes. Can you repeat, ma'am?
Yes. During your research work, you are
Mhm.
facing any privacy challenges with continuous health monitoring?
No, in my study, I do not face any privacy challenges.
And can your study compare with our real-time health monitoring frameworks?
Yes, it can be in real-time health monitoring system. It can be relate.
Okay. Okay. Thank you, sir.
Thank you, ma'am. Thank you.
Our next presenter for this session is Sidhesh Kulkarni, presenting a paper on the title Customer Retention Prediction. I request you to kindly take over with your presentation, please.
Hello, ma'am. Can
Hello,
you
sir.
hear me properly?
Yes, we can hear you.
Just a minute, I'll share my screen. Is it visible?
Yes, it is visible.
Okay, okay, no problem. Okay, uh, so just a minute. Okay. So, hello, my name is Siddesh Kulkarni, and we are excited to present our project titled Customer Churn Prediction. My name is Siddesh Kulkarni, and I would like to give credits to my author, Aditya Gorpade, Aditya Songirkar, and Aditya Chinchokar. We have conducted this work under the guidance of Professor Vaishali Langote from the Department of Computer Science and Engineering at DVK's MIT WPO Pune. This presentation is part of our contribution to ICT4SD 2025, where we will explore how machine learning can help businesses retain customers more effectively. Let's move to the introduction. In today's competitive market, keeping existing customers is more important and more cost effective than finding new ones. In fact, studies show how that acquiring new customers can cost up to 6 times more than retaining the current one. The problem is that customers leave. This is known as the customer churn. Businesses need to predict which customers are about to leave, understand the reasons behind it, and strategize how to retain them. And this is where the machine learning becomes powerful. It enables us to analyze customer data and behavior. So slide three's objectives. The primary goal of our projects are we want to predict the likelihood of the customer churn using machine learning models. Secondly, we aim to identify high risk customers well before they leave. Thirdly, we seek to understand the reasons behind churn using tools that offer transparency. And finally, we want to build a system that allows businesses to take proactive steps for customer retention. In short, we don't just want to flag a problem, we want to help companies and solve it in real time. Okay, so slide four is how we actually made this possible, our literature review. To build something useful, first we need to review the existing research and practices in the churn prediction. And we found that churn is usually driven by issues like poor service quality, hidden charges or fees, and pricing dissatisfaction when the customers think they are not getting enough values. So to add this, many companies use CRM system tools that store detailed customer data. These systems are increasingly being paired with machine learning and to make retention predictions. So popularly, ML algorithm used in this domain include logistic regression, that is great for simple yes or no predictions. Decision trees that they help uncover patterns like if a customer makes frequent support calls and low payments, they are likely to leave the company. And lastly, the most important, which is support vector machines, that is used for more complex decision and boundaries. And gradient boosting and neural networks, which is actually the backbone of our project, which performs well on large and complex data sets. So each algorithm has its strength, and our review helped us decide on the best combination for a system, that is to use them all and mix in one project. So, what actually was our challenges in the existing system? Of course, there are problems everywhere. So, however, existing systems aren't perfect. They face multiple challenges. And firstly, they have class imbalance. So, in real data sets, the number of customers who actually churn is much smaller than those who don't. Then we have, of course, the model accuracy. So, what works for one industry might not work for another. For example, a model trained on telecom data may not give accurate results in a SaaS or retail business. And lack of interpretability. So this is a rare case, but many machine learning models are black boxes. They give you predictions but not explanations. So business teams need to understand why a customer might leave, not just see a score. And also overfitting. Some models like decision trees may perform well on training data, but poorly on new unseen data, which reduces their real world usefulness. So, the next we move to a very important part, that is methodology. So, to solve these issues, we followed a structured methodology problem. So, first was the data collection. We gathered important customer information like age, usage frequency, payment history, and customer support interaction. Next, we focused on data cleaning. So, this step is a vital because raw data often contains missing values, duplicates, and outliers. And after cleaning the dataset, we did some feature selection using correlation analysis and tree-based important methods to identify which customer attributes were the most predictive of the churn. So then we came to the model building phase where we tried several algorithms like random forest, support vectors, logistic regression, gradient boosting, and even multi-layer perceptrons. So that was a very important part. The idea was to test a variety of models and to compare the performance. So, what did we learn based on this? How did we make the project actually? So, the system architecture is based on our findings. So, we built a robust, scalable churn prediction system. The core of our system is an ensemble approach which combines the strengths of multiple machine learning algorithms, which helps us improve prediction performances. And to address the interpretability issues, we use SHAP values, which allows us to explain individual predictions, which is crucial for business users to understand why the customer is leaving. So our system supports both batch and real-time predictions. So businesses can use it for weekly reports or to act instantly when a customer shows signs of leaving. And also we have enabled continuous monitoring and retaining, which is actually called as in simple languages, it is called as real-time database monitoring system. So meaning the model evolves with time and adapts to new customer behavior and market trends. So so our next slide is what algorithms we have used. I've explained this before, but still logistic regression is simple but very interpretable. Gradient boosting, specifically extreme gradient boosting, gave us the best performance. It is the most powerful in handling both linear and non-linear patterns and minimizes errors better than traditional methods. Next is our decision tree, the most famous algorithm that is ever used. The decision trees were great for visualizing customer decisions, paths, and building rule-based explanations. And then we have the neural networks, which helps us capture complex and non-linear relationships, especially when the customer behavior isn't easily explained using simple patterns. So that's when the neural network kicks in. And then, of course, we have the random forest, an ensemble of trees reduced overfitting, and which gave us stable results across different subjects of data. So, after all this, what did we actually achieve? Why did we do this? So, our best performing model was gradient boosting, which delivered strong accuracy and generalization. We also compare models based on the precision, recall, F1 score to ensure the predictions were balanced and reliable, especially considering the class imbalance. So additionally, SHAP values helped us validate the key factors influencing churn. For example, if a customer is in on a low usage frequency or delayed payments or on frequent support calls, reflecting that the customer actually has problems and might change the company. And overall, the model showed promising results for real world deployment with actionable insights and marketing and retention teams. We are pretty confident on that. And also real world impact. So if we were to talk about how this would impact the real world, the firstly, businesses can save significantly on marketing and acquisition costs, retaining a customer up to 6 times cheaper than acquiring a new one. And secondly, this model allows companies to act proactively instead of reacting after a customer leave. They can intervene early with discounts, better services, or personalized message, any how they proceed. And thirdly, it helps improve customer satisfaction and loyalty because the business is listening to warning signs and addressing the issues before they escalate. So that's what we want, right? That's what the customer wants. So that's good. So in the long run, this isn't about just reducing churn. It's about building stronger and resilient customer relationships. Okay, so the future scope I just explained. So real-time detection, it uses in-app activity supported by ticket history, enhances transparency using the both the algorithms Lime and SHAP. So and we have integrated it with the CRM platforms for automated actions. So these are the images of our model that we actually developed, predicting that the customer, when the customer is about to leave, in which month or age group the customer is leaving, and why he is actually leaving. So on the top right, we have tech support contact chart. So if this chart goes up, then it shows an error. So there is a problem. Okay, so thank you for listening to me so peacefully. I would love some suggestions or any questions you have. Please go ahead. I'm done with the presentation.
Okay, thank you for the presentation. And can you apply this model for different industries?
Right now, we have been able to apply this in the banking sector only. But yes, if we modify the algorithm, then it is possible to go into other sectors too.
And how much is your accuracy if we talk about the accuracy of your model?
So
Then
extreme. Okay, okay. Continue. Sorry.
yes, you can explain. We want to discuss about the accuracy of your model only. How much accurate it is?
Okay, so the thing is, we combined multiple models together and have made this actually made this model. But extreme gradient boosting algorithm has given us the most accuracy, that is 98.95%.
Okay. And what are the future scope you are thinking about?
The future scope might be some very simple at first. So if we were talk about 5-year plan, we would probably try to expand it in a different criteria, like leave the banking sector, go into financial sector, hospitalizing sector, medical, insurance, education, etc. And after some time, we may try to improve the accuracy and take the input from different algorithms. Like we can still add more algorithms to improve the accuracy. I still believe we can improve the accuracy of this model, so that might be the next 5-year plan if we were to look at the future scope.
Okay, thank you.
Thank you
Okay,
so much
thank
for
you,
your
ma'am.
presentation, sir. Thank you. Now, moving on, I'd like to call upon our next presenter for this session. Our next presenter is Sharon Koshi, presenting a paper on the title Harnessing AI and Biomimicry for Resource Recovery, Advancing Circularity in Smart Infrastructure Systems. I request you to kindly take over with your presentation, please.
Yeah, thank you so much. Thank you to the respective committee for giving our team the opportunity. Can you hear me? Sorry.
Yes, yes.
Yeah. Yeah, for giving us the opportunity to present our paper. We are truly, we truly appreciate this platform to share our work. And since this paper is quite extensive, I may need to move through a bit quickly to stay with the time. So I hope you will kindly bear with me as we do so. So now coming to the, the topic of a paper, it's about harnessing AI and biomimicry for resource recovery, advancing the circularity in smart infrastructure systems. So going to the, coming to the introduction. Yeah. Okay. Obviously, this is presented by myself and my colleague, and his name is S. Patmadas, and we both are from Rajagiri College of Social Sciences. And going to the next slide. Yeah, about the significance of the study. Before talking about the research, I would like to say a few facts. As of November 2022, the global population reached of almost 8 billion, and it's expected to peak at around 10.3 billion by the year 2080. So with this growing comes a massive rise in the resource consumption, and it is projected to increase by 60% by the year 2060, which is obviously driven by the urbanization and industrialization. So we are already facing all these consequences right now. We have got this climate change, we have got this biodiversity loss, we have got this pollution and even the water stress. So basically, we are suffering on the triple planetary crisis. And whereas the material use, it have jumped to almost 27 billion tons from the year 1970 to 100 billion in the year 2020. And if we stay in this path, the pressure on our planet will only, it get worsened. So today, the humanity, they consume the resources equivalent to 1.75 Earths. And, if you can remember, in the year 2024, the Earth overshoot day fell. It was on July 25, where when the Earth overshoot day happened, which means that we have used up a complete year's resource in just 7 months. And when you talk about emissions, it also hit hard. A record of 36.8 billion tons of carbon dioxide was in the year 2023, and we produced billions of tons of waste from the food to electronics. Yet the process of recycling, the rates remain critically low. So the number, these numbers, they are like a wake-up call for us. We must rethink how we live, how we build, how we grow, and that is where our study steps in. Getting into our topic, I'll just give you a glance. Let me just take you through the step-by-step flow of the study, starting with the root of the problem and moving towards the proposed solution. So starting with the step 1, which I've mentioned here, the problem identification. So we began with a critical question. What is driving the rapid depletion of our natural resources? So the answer lies in the unexpected population growth, urbanization, industrialization. So these forces have led to unsustainable consumption patterns that are actually putting enormous pressure on our planet. Second comes the ICT and the smart infrastructure impacts. Ironically, these sectors, they are meant to enhance the efficiency, like information and communication technologies and smart infrastructure. They are adding to the problem in very several ways. Third, going to the identifying current systematic challenges beyond the individual issues that we are facing right now. The real challenge is systemic. We are opening, we are actually operating within the broken infrastructure models. Say the recycling systems, they are outdated. Waste to energy technologies, they are actually faulty. And even the water management, they remains actually unsustainable. And then here comes the call for action. This leads to a very urgent call. We need a paradigm shift in how we manage our resources, which is driven by evidence-based policies or technological innovations. So we have to think about it. So for that, the solution that we have proposed is bringing in the technological enablers. The role of AI comes in place here, and also linking it with a nature-based solution, like the role of biomimicry. And thereby, when you bring all these things together, we are actually proposing an integrating approach, the core of our research. The heart of our research lies in this integration of the approaches of, as I said, the technology as well as the biomimicry. So by combining these, we are coming up with a wisdom of natural system through biomimicry in order to, come up with a sustainable solution for the future. Now, going to the next slide. Yeah, obviously, our topic is directly related with the 4 SDG goals of 9, 11, 12, and 13. Going to the next slide, please. Yeah, introduction part, I have already mentioned, so I don't want to waste time on the introduction. Can I go to the next slide, please? Yeah, just to give you an idea on, what is the core pillar of our study? It's none other than biomimicry. So at its heart, biomimicry is basically a sustainable design philosophy that looks into nature, not just for the inspiration, but for the instruction. So basically the concept is it draws from the nature's time-tested patterns and strategies to solve the modern human challenges. So basically we need to understand this biomimicry or the nature as a model where, we start studying the forms, the processes, and the systems which is found in the real world, real natural world. For example, the structure of the lotus leaf, it is actually an inspiration for self-cleaning surfaces. The termite mold, they obviously inspire the passive cooling in buildings. In the same way, nature can even act as a measure. Nature also gives us a benchmark, a way to evaluate how sustainable or efficient we are. And nature can also act as a mentor, wherein, it's a very best teacher. Biomimicry actually urges us to humble ourselves before the intelligence of ecosystem. So it moves beyond seeing the nature as a resource and instead positioning it as a source of wisdom. So basically, nature can act as a teacher as well. Going to the next slide, please. Yeah, this is the methodology that we have used. We have used the literature review, and we have used the SPARK 4 SLR framework to identify the study. And accordingly, we have identified 4 themes to do our literature: biomimicry-based technologies, nature-inspired algorithms, swarm robotics, and bio-inspired water and energy systems. So in a total of 31 papers were analyzed. When you go into each and every topic, the first one is biological analogs for autonomous repair and recovery. So here, as I said, nature has they have inspired scientists to create materials that can actually heal themselves, just like the plants and animals do. So by mimicking the processes like blood clotting and plant wound sealing, researchers developed smart materials, just like the polymers, which has got the tiny channels that can actually release the healing agents when damaged. So this can be implemented in the new, smart cities so that you are actually reducing the waste and you're using the resources more effectively. Now, going to the next one, I'm just rushing here. Going to the next one, incorporating the ecological intelligence in intelligent building environment. So here architects are now turning to nature to design a smarter green buildings. So this approach is called the biomimicry in architecture. It uses the ideas from plants, animals, ecosystem to actually manage the heat, water, energy, and everything efficiently. Instead of just copying what is in the nature, basically the shapes, today's design mimic how the nature functions, like using the algae to treat the wastewater or capturing the carbon. So with the help of AI, robotics, and smart materials, buildings are actually becoming more adaptive, eco-friendly, and regenerative. Okay, going to the next one. Yeah, next is about the nature-inspired algorithms. So nature-inspired algorithms, they are like smart computer methods that work by copying how the nature solves a problem. For example, they learn from how the birds fly in the groups, ants find the food, and how the living things evolve. So these algorithms, they can be used to solve big problems. I would say tricky problems like managing the electricity in smart cities, or improving the traffic flow, or even saving the water and energy. This can actually play a very important role. Now, getting into the last, swarm robotics. So here, it is like an emerging field inspired by the collective behavior of the natural systems like the ant colonies or bird flocks or even the beehives. So it basically involves multiple simple robots working together through the centralized coordination, where each unit follows a local rules without a central controller. So this actually can lead to self-organization and emergent behavior, allowing the group to solve some serious problems effectively. Now, getting to the next one, we'll talk about the bio-inspired water and energy system. systems. So this is like a cues from the nature to develop innovative, sustainable technologies for a clean water and renewable energy. So researchers, they have already created special materials and surfaces that can mimic the structures of the plants and animals to actually enhance the water harvesting, purification, and energy conservation. So, for example, surface modeled after the insect beetles or the lotus leaves use microstructures and unique wettability to collect the atmosphere moisture effectively. So these are the things which we have identified from the literature. Now we have, can we go to next slide, please? Now we have proposed a model which would be taken care by Fatma sir. Sir, can you please?
Thank you, Professor Sharon, for the wonderful, splendid introductory program, things related to the topic of presentation. So I believe I'm very audible to you and the screen is visible to you. So I'll be taking through the ISIMS model, which we just talking about. It is called the base expanded base integrated smart infrastructure for modular sustainability. So based upon the various problems which we were actually facing, our world economy is actually facing, we just made a prototype relating to the part of an element of a solution-based program, like, the integration of something called as well ISIMS. So ISIM talk about a philosophy like, which is combining the principles of biomimicry, swarm robotics, self-feeding materials, and bio-inspired architecture and nature-inspired algorithm. So as you can see from the screen here, right here itself, we actually have a model paradigm based upon the percussions of the biomimicry and self-healing system, bio-inspired architecture, swarm intelligence, genetic robotics, and various things. So the data integration, scalability, real-time feedback, and resource recovery optimization talk about every of these individual perspective related to the part of the limitations and the maximum framework which has an which is with the program is actually scalable to adapt in the current scenario. So the system which is actually implemented in the current scenario in the world economy is actually having some kind of limitation. So for that, we are actually integrating a framework which is called the basic ISIM, or the integrated smart infrastructure for the modular sustainability. So the importance, or the what are the various important factors relating to the implementation of an ISIM, which we will be talking about, are the fact that the ecological sensing, we will be having a huge positive impact relating to the part of prediction towards ecological sensing, circular material flows, automotive resilience, evolutionary learning, and the regenerative energy. So I believe that I understand that it's a little complicated related to the part of technical theory, but let me take you through the actual framework related to the working model of the theory. So the ISIMS framework, or the integrated smart infrastructure modular sustainability framework, is actually talking about two basic things. The first one is talking about the nature-inspired computation layer, and second one is talking about the bio-inspired intelligent layer. So talking about the operational layer, we talk about this situation or something called, swarm intelligence. It simply talk about the situation that how a human lives and how a ant or a particular swarm or a firefly or a bee lives in an ecosystem. We don't see any part of waste particles or any programs or
I'm
any fossil
really
fuel.
sorry to interrupt, sir. However, we have crossed the 10-minute mark. I request you to kindly conclude as soon as possible. Thank you.
Okay, sure. So this is a model which we created. So the first one of the nature inspired will be based upon how the animal lives and how they manage the waste. And we should be comparing how the animal lives and they live in an ecosystem, and how the humans are living, how much of the waste we are polluting into the environment. And the bio-inspired is talking about the composting, waste generation, composting, how the river flows, and about how the forest is generating itself. So talking about the situation of the ISIMS again, the ISIMS have this much of an importance, like, these will be having element related to the part of biomimicry, talking about industry symbiosis, to be very specific. You know what exactly industry symbiosis, I believe. So because the waste of one industry will be used as a resources or the raw material for the other industry. For example, let's say take about the situation of the construction site in here. The waste which is generated from the construction site will be used for the recycle centers in here. Likewise, everyone is using the elements of this industry symbiosis. So this is another of the model which I don't have the time to explain in about. So technically talk about the situation that we just introduced a framework which is called the BSI ISIM, and to talk about the two perspective, nature inspired one and the bio inspired one. Nature talk about how the animals live in and how much of the emissions of the pollution which they are actually emitting, and the bio talk about how the system actually working, and you talk about a situational philosophy that the element of the integrated smart infrastructure modular sustainable the ISIM can be integrated to any of the requirement situation, like the policy sandboxes, government participatory council, any of the economic barriers, political programs, and whatever things which we are actually the industry or organization or the world economy is having, we can implement the program of ISIMS, and we can just make a situation of sustainable development, sustainable growth. Thank you.
Thank you so much for your
Okay, thank you,
presentation.
sir.
Yes.
Okay. The question from my side is, can your work be scalable to smart cities?
Pardon, I couldn't hear you clearly. Can please repeat the question once again?
I'm I'm asking you, can your work be scalable to smart cities? We can apply it for
Yeah,
smart cities.
that is what we are looking as of now. This is just a conceptual paper, ma'am. We would like to take it to the next, level wherein we have to actually look the practicality of implementing the model.
And would you have apply any feedback loop for this system?
Not actually. We have just taken it
Okay,
in the
so in
conceptual
future
side.
work you can
Yeah.
apply it
Yeah.
for the your future work as
Yeah. Yes, ma'am.
well. Okay, thank you.
Thank you so much. Thank you. I'm really sorry we were so much rushing because it is a very expensive paper. We could, the only thing is, just run off the slides. I'm sorry for that. Yeah.
Thank you so much for your
Okay.
presentation, sir, ma'am. Now I would like to call upon our next presenter. Our next presenter is Prakriti Gale, presenting a paper on the title Opinion Mining of YouTube Video Comments Using Machine Learning and Deep Learning. I request you to kindly take over with your presentation, please. Okay, so since Ms. Pragati is not available with us right now, we'll take upon our next presenter. Our next presenter is Omkar Kalantri, presenting a paper on the title Optimized Bounding Box Fitting Method for Object Detection. I request you to kindly take over with your presentation.
Hello, good morning everyone.
Yes, sir. You can start with the presentation.
Hello, is the presentation visible?
Yes, sir, it is.
Hello everyone, myself Omkar Kandre. Today I will be presenting the novel approach titled the Optimized Bounding Box Fitting Method for Object Detection. Authors for this work are me, Omkar Kandre, and Dr. Jyoti Joglekar. She is my guide for this project. This is the outline for the today's presentation. Introduction. So object detection is basically the process of detecting the presence of object in surrounding. The for object detection, accurate bounding box are crucial for detection ability, and poorly fixed boxes lead to the misclassification and reduce precision. Traditional bounding box methods have the fixed anchor size and poor adaptability to object shape and scale. Our motivation is to improve the bounding box precision without increasing the computational load. For this study, we have studied the multiple technical papers and found that the existing methods mostly use the multiple sensors, which require the higher computational cost, or they are with the go with the CNN method, which requires the explicit training. Such methods are deep learning based, which requires a high amount of data and training time and cost. So our goal in here is to improve the bounding of precision without going in training models. So some methods also use the fast CNN, mostly CNN based methods and various classifiers. This papers also this paper also include the review papers which are talk about the all various methods available for object detection in the market. So our objective is to reduce the training time and computational resources. Design of our object detection system based on the computer vision and machine learning methodologies, and development for of object detection system using CVML methodologies, and to evaluate the performance of proposed system. Our whole project includes the vehicle as an object for but in this paper I'm only presenting the object detection and bounding box part, which is the first half part of the whole project, which includes the determination of block size and thresholds, creation of binary image, and selection of appropriate object, and plotting the bounding box around the uh, uh, object, or finding the region of interest. This is the overall block diagram for the research study. Uh, this flowchart here shows the step-by-step method of step-by-step steps for the drawing bounding box on the required object. So first is to load input image. images have been get from the CCTV footages at the various societies. Yeah. The second step includes the determination of block size and threshold. Next is the initializing the binary image. Uh, After that, after initializing binary image, which is basically a black image, we go in a loop for each block in the image. We calculate the mean color of the block, and if the color is mean color is in the within predetermined thresholds, we take it as a white, convert the binary image pixel as a white as a part of the object. Otherwise, we mark it black or keep the black as it is as a part of the background. Then initial binary image is generated after the whole image is covered and all blocks have been calculated. And then we select the appropriate counter based on the after performing the noise reduction and other morphological calculations. Select the appropriate counter. We also use the location and size parameters for determination of the appropriate counter. Then we create the and save the final binary image, which includes the only selected counter. And then we determine the bounding of coordinates using the 4-point method, where we find the highest, leftmost, rightmost, and bottommost the white pixel. And then we determine the bounding of and plot the same on the original image. Uh, and, this is the pseudocode for the bounding box algorithm. Implementation and results. This system is implemented using the Python, and OpenCV method is used for the comparisonal view. The first image here, figure 6a, shows the input image, and 6b is the initial binary image generated from the input image. Figure 6c shows the largest selected counter. And figure 6d here shows the output using the inbuilt method, which is available in OpenCV package, which is called find counters and plot bounding rect. And the final image here, figure 6e, shows the output using the developed method. Here are the similar results using the different images as input. Here are the same implementation. Also, we have included one another model. If background is available for the model, then the bounding box are the more precise and accurate. So in this figure 8a shows the background image, and 8d shows the image with the object of interest. Same 8b and 8c shows the initial binary image and selected counter. And finally, image 8 shows the more precise application of bounding box. Here are some other results which has been gathered from the proposed method. For result calculation, we have used the precision, recall, F1 score, F2 score, IOU, which is intersection over union, and accuracy. This table here shows the comparison between the comparison for OpenCV inbuilt method and proposed algorithm for drawing bounding box using this matrix. In conclusion, the novel algorithm for optimized bounding box fitting has been developed to enhance the object detection accuracy. The method effectively reduces the background clutter, and result is more precise as the region of interest. It offers the computationally efficient alternative to deep learning methods, and making it suitable for real-time and resource constrained applications, overcoming the limitation of manual and traditional region of interest selection systems by providing reliable bounding box fitting algorithm. For limitation and future work, I will say we are implementing develop this method for the vehicle as an object. So this performs best on the medium to large size of objects, but performance on the very small size of object can be improved in the future work. These are the important references. Thank you. Hello, ma'am.
Hello.
Yeah, is there any questions, ma'am?
Yes, your method can be integrated with the real-time detection system.
Yes, ma'am. We are developing it as for the real-time detection, as our goal is for vehicle detection for CCTV, real-time CCTV footages. So the main method to not use the deep learning based method and reducing the computational cost is to implement it in the real-time data applications.
And as the future scope, on which data set you want to treat this model?
Ma'am, we are using the real-time CCTV footages as a data for our system.
And you have taken the data set from where?
From various societies and our college improvises.
Okay, so you have tested your model on how many images?
Uh, for, most images are
Around you can approximately give the count.
yes, ma'am.
You can approximately give the count around how many images you have trained your model.
Ma'am, this model do not require the explicit training as it does not involve any training or deep learning methods. We just need to tune the thresholds as per the background we are working with. So
Okay.
we can say after uh, tuning the threshold for each background, we can use this for as much we like.
Okay, okay. Okay, thank you.
Thank you, ma'am.
Thank you so much for your presentation, sir. Now I'd like to call upon our next presenter for this session, Mohan Selappa Gondar, presenting a paper on the title Optimizing Road and Pothole Segmentation on Indian Traffic Data Using Pre-trained Computer Vision Models. I request you to kindly take over with your presentation, please.
Thank you for your time. I just joined because I was in the other virtual room accidentally because it was supposed to be presented by my students.
Okay,
Give
sir.
me a minute. I just got my PowerPoint. I'll just take it from here. Give me a minute.
Sure. So if you want, we can take anybody else before you if you want.
Yeah. If you can give me one more paper in between, I'll be ready by the time.
Okay, okay. So I'll just take call upon our next presenter meanwhile.
Thank you.
Our next presenter is Pranav Parthe. Pranav is presenting a paper on the title Precision Agriculture Enhancing Crop Selection and Yield Forecasting with ML. I request you, if you're available with us, to kindly take over with your presentation.
Hello, am I audible?
Yes, you are.
I hope I'm audible. Yeah, just give me 1 second. I'll share my screen. Hello, I'm so sorry. It's just my neck.
I can do it. This is Dr. Mohan. So if you want, I can do it now.
Okay, I'll present it.
For sure, sir. Sir Pranav, we'll take Sir Mohan sir first now. You
Yes,
can just, get
I'll
back to
fix
us
this.
with, yes, please
Yes.
fix your network issues. Okay, thank you. Requesting sir, please, Mohan sir, kindly please take over with the presentation.
Yeah, I've done that.
Okay, thank you so much, sir.
Yeah, this is my topic. Hope you're able to see my screen.
Yes, sir, your screen is visible.
All right. So there was a last minute, sorry for the miscommunication between my teams. There are supposed to be my students presenting the paper. They are held up in their company where their laptops are not allowed. So I'm sitting right now in the US and presenting this paper. So in case if you find anything related to our college and things like that, this PPT has been prepared in the last minute. That PPT which has been prepared for this presentation has not been shared right now with me by my students. So we are physically in a different place. Anyway, so the topic is optimizing the road and pothole segmentation on Indian traffic data using pre-trained computer vision models. So the work was actually a small byproduct of a bigger project that we have been working with the Bangalore Traffic Police. This is on collecting the data from various, dash cams and then identifying the potholes. Only on that particular part, this paper is focusing on. So the idea is that all of you know that in the road pothole segmentation is a very crucial task in case if we go for the autonomous driving and road safety applications. So this involves taking the images from the live cameras, live feeds from the cars, something like dash cams, and then segmenting them into identifying the road surfaces, potholes, and other key features. So the issue with the existing models like OLO is that the potholes are not directly being identified by the models because the potholes are in different shapes and different sizes. You know that some of the potholes may not be even visible on the road surface. So we need some kind of model that can actually segment the road from the other part of the surfaces. So we tried to explore a model called Dino, which is a self-supervised transformers for the road and pothole segmentation by applying the ResNet 50 and UNet, which was focusing on advanced deep learning techniques to achieve somewhat accurate and efficient segmentation. So in this work, which has been showcased just to identify the segmentation, so here we have addressed the challenges by utilizing these ResNet 50 and UNet to develop a robust and scalable segmentation method that performs effectively across diverse real-time situations in which we have taken some of the data set from real road conditions from Bangalore city. Right, so the ultimate objective is to achieve enhanced road maintenance planning and the safety issues, and also address this as a solution to the autonomous vehicles. So obviously, when this kind of applications are developed, we also can monitor the infrastructure as part of the city development, and we can help the city to better monitor, because the potholes are not something which is very static, which are all very dynamic due to various environmental situations like the rain, flood, and all. So we have taken one of the base papers, very basic reference like the Dino, which is towards unified transformer-based framework for object detection and segmentation. So this is our basic reference paper, and also we have applied certain segmentation papers on UNet and autonomous driving. So there are some more papers which you can see here: deep residual learning for image recognition, real-time pothole mapping based on vibration analysis in smart city. There are a few more papers which are listed out here, which are recently been published in the last 3 to 4 years. So coming to the ResNet, we have explored that it has various stages and various blocks, the model. So we haven't used anything else other than this ResNet model to analyze how much it can give accuracy in terms of our data set, because we have collected more than 500 video sets from the dash cams of the cars across the city. And there is a separate work which we have already published, as I think one of this in the conference itself, in this conference itself, another work has been published, where we have majorly used remodeling of YOLO to fine-tune our data sets. And last year we have published a paper on the data set itself with various categories of the road conditions. For example, we have data sets which have animals on the roads, the vehicles coming in the opposite side, the vehicles on the service roads, vehicles on the highways, and the vehicles where the signboards are visible, and many other things that we have classified the data set, and that's available in the public domain. If anyone is interested in downloading it, they can download it. So we applied that data set on this ResNet model to check how much it can recognize the pothole. So it has 7x7 convolution, 64 filters. That's the initial layer, and there are 4 convolution stages. In the stage 1, we have 3 bottleneck blocks, which has a 256 channel, and then 4 bottlenecks in the stage 2, which has 512, and then it doubles up every stage. So the output layer, we have the global average pooling, which converts the feature maps to a single vector. We have the fully connected layers, which gives the output class probabilities whether that surface of the road belongs to pothole or not. So this is further the technical architecture of the UNet, other than the ResNet. So the UNet, we have encoder and decoder. We also have skip connections. So the encoder captures the context and extracts features from the input image. The decoder reconstructs the spatial information and generates a segmentation map. And the skip connects link the encoder and decoder at corresponding levels, allowing the model to combine low-level spatial information from the encoder with high-level contextual information from the decoder. So we have a few data sets, which these are all from the standard data sets, which is not from our standard data sets. So just to have an understanding of how the potholes can be identified. So what has been mentioned is actually it is about more than 1,000 images. Sorry for the typo there. From the dash cam videos, there are two classes which are roads and potholes. We were not interested in anything else. Actually, there are some works going on in identifying the unmarked humps as well, because that also leads to some of the safety issues. And also some of the construction areas and things like that. That's not anyways part of this paper, but here we have only focused on identifying the potholes. So we have different resolutions of the images because the dash cams capture the video in the 720p, but then we had to resize them into 512 by 512 for training and inference. And looking at the model for the entire architecture of implementation, the flow is that the video is converted into frames, and then you can see here we pass that to the model which is pre-trained to segment the pothole. And we also analyze overlap both the segmented images and finding out the pothole and segmented images where the segments are part of the potholes. So we applied this on more than 1,000 images, and the accuracies are listed here. Okay, so this is for the road segmentation, and this is for the pothole segmentation. You can see here with the training and validation loss over several epochs. And this work is an ongoing work, and still we are working on identifying various objects on the road. I think I'm coming to the conclusion. Thank you so much for the opportunity.
Sir, there is one question regarding your presentation. How you are evaluating the poor lighting images?
Yeah, see, poor lighting images are not considered. Particularly, we also had situations to take the night images. For example, from the dash cam, we have collected the night videos, but then that has not been considered here. It is a big challenge because we also have to depend on other external sensors like the radar. That's part of the the ADAS level 2, where the cars are equipped with those devices. But as the computer vision models, we have the limitations of using this the night vision. We can apply the night vision cameras, but then night vision cameras also will have limitations on the coverage, the distance at which it can capture. But we can integrate that with the radar and then find out if that can help us. So that's still not considered in this work, but we have considered it for future work.
Okay, thank you. Thank you, sir.
Thank you.
Thank you so much, sir.
May I leave because I have to get ahead for another meeting?
For sure, for sure. Now I would like to call upon Pranav Temse if you are available with us.
Hello,
Okay. So
I'm audible.
yes, you're audible. Can you present now?
Yes. Actually, so sorry. There's a power outage. So my PC is gone
No
black.
issues. Now I request you to kindly start.
I hope the screen is visible now.
Yes, your screen is visible.
Okay. Good evening, everyone. Myself, Pranav Temse, and today I'll be presenting a paper with the title Precision Agriculture and Enhancing Crop Selection and Yield Forecasting with the help of machine learning. So, firstly, we'll begin with the introduction to data-driven agriculture. Our research addresses two distinct but interconnected agricultural challenges, that is crop recommendation, which is we can say classification problem, since we have to predict the best crop from a set of options. And the second one is crop yield forecasting, which is a regression problem. So for both tasks, we have gone with a comparative approach, which we have taken by evaluating multiple machine learning algorithms to identify the most effective ones. So there are basically three steps that we have done. First is optimized crop selection. Second one is accurate yield forecasting, and the third one is sustainable farming. So in optimized crop selection, we guide basically we have a whole system set in place, which when we enter the parameters of there are multiple parameters that a farmer can select, for example, the NPLK level, the soil moisture, etc. And the system will suggest the best crop which the farmer can plant. And the second one is accurate yield forecasting. So based on past data that we have of the area, or whenever the farmer has selected the crop, then they can the size, that's the area of the land, and a few other parameters, and then the yield will be forecasted. And this will help in sustainable farming. That's the third option. So what person can do is basically if they have a chunk of land, then maybe they can optimize it by planting two crops at the same time. Reduce, and then rather than switching it in off season, on season, like that happens in Punjab when they switch it. So that is one of the reasons. So with the data set and processing methodology. So as I mentioned earlier, some of the parameters that we have is NPK, pH level, the temperature, humidity, rainfall, historical crop yield. So these are some of the parameters that we use for both crop prediction and the crop yield forecasting as well. Next, we have done pre-processing steps. That includes median imputation for missing values, since a lot of the pH values we have to do that. Also, many values are missing, so we had to take a note of that and we had to get an approximation value. Then Z-score normalization is one of them, and feature selection. So we can remove irrelevant attributes like production, the year. That doesn't have that much of an impact as much as other values do. Moving on with the crop recommendation system that we have. In this, we have gone with three algorithms. The first one being logistic regression, second one being support vector machines, and the third one being gradient boosted classifier. Linear regression was used as a baseline model, while with that we achieved an accuracy of 92.1%. With support vector machine, we achieved an accuracy of 96.1%, and with gradient boosting, we achieved the highest accuracy of 98.18%, and an F1 score of 0.980. So this showed us that gradient boosting is much less suited for this crop recommendation compared to other things. Moving on to the crop prediction models, we went with XGBoost, random forest, and extra days regressor. And out of this, we achieved an accuracy of 91% with XGBoost, 95.1% with random forest, and the highest accuracy of 96.21% with extra T regressor. So that's what we have gone with. Also in the extra T regressor, yes, so we achieved the R square score of 0.9. So in essence, the research employed a systematic data-driven approach, you can say. So with that, we are carefully selecting which crop we have to plant and also predicting the yield that it will give. Moving on, we currently have a deployment and user interface for that. It's an intuitive HTML and CSS JavaScript. Actually, the image is not loading, but it's right here. So I'll give you a brief idea of what it is. So for the first part, the farmer will input what all soil pH, which is the NPK values and all that, which most of the farmers already have. So their soil pH level, the moisture level, etc. And based on that, the system will suggest which all chemicals should plant. Actually, while testing this, one of our group mates have a farm, and in that the people in the surrounding neighborhoods actually tried with them. 9 out of 10 times the crop that they were going to plant, for example, wheat, whatever, our system also predicted that same exact crop. So this was for system deployment and user interface. Moving on to agriculture productivity and sustainability. This will enhance the productivity by a lot, because compared to current scenarios that the farmers have, that is just based on historical reliance. Like if a farmer if they have a new land, their great grandfather or their fathers, whatever they done, they used to do the same. But with the help of our model, maybe they can try out some new crop, which will increase in precision and might give them a greater output. So this is one of the key impacts that our model will have. Moving on with future scope and innovation. So there have been many models in the past, but our model differs from those in many ways. The first one being dual functionality. It provides integrated crop recommendation and crop yield forecasting as well. Second one is advanced machine learning algorithms with rigorous testing. So we have implemented three algorithms for each. So three algorithms for crop recommendation and three algorithms for yield prediction. So that minimizes the chance of errors by a lot. It's a very low margin of error that a person can get. The third one being real world impact. What we plan to do currently, our system is based only on the laptop application, laptop executables that we have. So what we plan to do is currently in current world scenarios, almost all of the farmers have a mobile phone. So we are planning and working on right now making a mobile application. So just on their mobile, a farmer can enter all of the values and they can get the recommendation and also the yield prediction. So that has a very big advantage of being a user-centric design and accessibility. This is much needed for current generation's farmers, as you can say the technology and internet and IoT devices have just reached villages and everything. So if they have an application that lets them do all of these things, it will be a huge benefit for them, in our opinion. So in conclusion, our project stands out by offering a comprehensive, highly accurate, and user-friendly machine learning system, which integrates both crop recommendation and yield prediction, directly addressing the critical challenges that the current agriculture industry faces. Yes, that's it. Thank you. If there are any
Okay, thank
questions.
you. And whether your model, in your model, soil and weather data will play any role
Soil
or it
will
will
play a role.
change?
Oh, sorry, go ahead, go ahead.
You can continue. The question you can understand, I think.
Yeah, okay. So we have initially tried with weather as well. The soil level, it will be tested. So the soil pH, the soil moisture, that has to be taken into account. We also tried incorporating the weather, but weather weather is such an unpredictable factor that we really cannot take into account. So, and also the data set that we had, it had very vague information about weather. So, for example, this year in the entire Marathwada region, the rain started approximately 15 to 20 days earlier. So, if we put that into any regular system, that would have recommended the wrong crop or the wrong timing. So, weather is something that we cannot currently incorporate, but as weather predictions are getting more accurate day by day, we hope and plan to incorporate this in the future.
And there are any limitation if we are thinking about your model to be in scale?
Limitations, limitations as such, there will be firstly, it will be that it's not as such of a limitation, but that whatever the parameters that we have entered, that a farmer needs to have. For example, the potassium level of the soil, the pH, the moisture, everything. Currently, all the farmers do perform this test, but there might be a small portion that does not have this information, and that might prove a bit challenging for them. And apart
So
from
you
that,
can go for the sensors part also.
yes. So
So
I
you
was
can
actually going to
progress your
come.
work. Yes. You can expand
So,
your project related to using IoT and sensors.
yes, yes. So actually, I was going to come to that.
So
So for future
in
scope, we
real
have
world
planned
also
one.
it can be applicable.
Yeah. So continue. So sorry to interrupt.
Okay, thank you.
So yeah, that's. Thank you.
Thank you so much for your presentation, sir.
Thank you.
Now I would like to call upon our next presenter for this session. Our next presenter is Vanshika R. Kavi, presenting a paper on the title Semiconductor Wafer Fault Detection Using Machine Learning. I request you to kindly take over with your presentation, please.
Hello, ma'am. Is the screen visible?
Yes, your screen is visible.
Good afternoon, everyone. I am Vanshika Kavi from KLE Technological University, Hubli. I am presenting my research on semiconductor wafer fault detection using machine learning. So, what is a wafer? A wafer is a thin slice of semiconductor material, usually silicon, used to integrate circuits. These wafers go through multiple processing steps and can be subjected to defects at any stage. This brings me to the importance of fault detection, as even a microscopic fault can lead to device failures. Early and accurate detection of these faults ensure high yield, reduce waste, and produce reliable chips. The challenges with manual methods and rule based methods are manual inspection is time consuming, inconsistent, prone to human error. Rule based systems lack adaptability and usually fail to detect complex, non obvious patterns. The motivation behind using machine learning is it offers the ability to automate the process and reduce manual intervention and inspection time. The objective of this research is to use machine learning for automation of the process and make it faster, scalable, less error prone, and classify the wafers as good or faulty using sensor data. Before diving into the work, to understand the existing approaches in wafer fault detection, a detailed literature survey was conducted. Here is a summary of key findings from recent works. The methodology followed in the research begins with sensor data collection, pre-processing the data, performing feature extraction, training the machine learning models, testing and evaluating the model performances. The data pre-processing includes handling missing values by filling them using median values so that useful features are not discarded unnecessarily. Feature selection, which removes low variance and highly correlated features, reduces the noise and improves model efficiency. Feature scaling, standardization using Z-score normalization. Class imbalance handling, which is done using synthetic minority oversampling technique, which generates artificial samples for the minority class and hence balance the class distribution. Feature extraction, SHAP analysis is used to determine features that influence the classification decision. A set of supervised models suitable for classification tasks were explored. They are support vector machine, which is effective in handling high dimensional data and separating the class using an optimal hyperplane. Random forest, which demonstrates strong generalization and robustness to noise, handles feature interaction effectively. Logistic regression, which offers a simple and interpretable approach to binary classification and serves as a strong baseline model comparison. K nearest neighbors, which is an instance-based learner that makes prediction based on proximity of data points. Each model was chosen based on its unique strength in handling different aspects of the data set. Once the models were selected, we proceeded to train them. The training strategy included 80 is to 20 data split, in which 80% of the data was used to train the model and 20% of the data was used to evaluate the model's generalization ability on unseen wafers. Grid and random search for hyperparameter tuning. Grid search offers exhaustive tuning and random search performs fast sampling. A combination of both helped in reducing the computations. Evaluation matrices such as accuracy, precision, recall, F1 score were used to identify faulty wafers. Models were optimized and evaluated for generalization. After training and testing, the models were evaluated using confusion matrix. As it can be seen, support vector machine achieved good balance in correctly classifying both classes with minimal misclassification. Random forest has fewest false negative, making it highly reliable in catching actual faults. Logistic regression struggled to classify fault wafers and has more false negative, which is risky in manufacturing context. Hence, it can be said that support vector machine and random forest achieved high accuracy for fault classification. In comparison, it can be said that, referring to the table, support vector machine and random forest performed with great accuracy with 99% and 97% respectively compared to logistic regression and KNN. A high recall indicates that The model correctly identifies the majority of defective wafers. KNN struggled due to high dimensionality. In conclusion, our work demonstrates that ML can automate fault detection with high accuracy and outperform manual inspection. Support vector machine and random forest are suitable for structured wafer data and are highly effective for fault detection. Pre-processing steps like feature selection and class balancing are critical. The future scope involves integrating the models with real-time systems, exploring semi-supervised learning for unlabeled data, ensemble optimization, and deep learning. Thank you.
Okay, what challenges you are facing during this your research work?
The main challenge was data imbalance, ma'am. It was overcome using synthetic minority over sampling technique.
And can your work be integrated with any existing manufacturing system?
It depends on the data set, ma'am. As the data set had only sensor data values, this was the approach. The traditional machine learning methods was taken. Depending on the input data, if it is images, it can be integrated with other deep learning models, ma'am.
So you are facing any challenges in obtaining the labeled wafer data?
Yes, ma'am. The label data availability was not there, ma'am.
Okay. Okay, thank you.
Thank you, ma'am.
Thank you so much for your presentation. Now I'd like to call upon our last candidate for this meeting, Aishwarya Khubare, presenting a paper on the title Smart Hostel Security System Using Face Recognition for Enhanced Access Control. I request you to kindly take over this meeting.
Yes, thank you, Prashi. Yeah, so I'd like to share my screen. So just let me know once it is visible.
Okay.
Yeah.
It is visible to us, ma'am.
Yes. Yeah. So firstly, I would like to thank ICT for the opportunity for presenting our paper. So yeah, I'll start with the presentation. So yeah, our paper ID is 941. So our presentation is related to smart hostel security system using face recognition. So with me there is Piyusha Shetgar ma'am, Asha Thalange ma'am, and Rohini Megu ma'am. So yes, we are all representing WIT Solapur. So I'll just quickly start with the presentation. So this is the smart hostel security system using face recognition. So this is a quick layout of our presentation, today's presentation. So I'll just quickly start with the introduction. So yeah, face recognition is a biometric technology that goes beyond just detecting human faces or images. So it is a bit more further. Face is a primary identity of any human being. So using this, we are uh, setting a hello. Hello.
You are audible.
Oh, okay. There was some glitch at my end. Sorry. Yeah. So this hostel security system uses IoT-based security system that detects face, whether the person is known or unknown to the database entry. So yeah, this is the basic introduction. So the purpose of this system is to develop facial recognition based hostel security system that aims only authorized individuals into the premises, and to enhance the security system and reduce the manual intervention here. So objective is to develop a monitoring system using face recognition to provide automated system and to build a user-friendly interface with security. So yeah, the basic requirements of this system is like we need a Raspberry Pi camera module, MCU buzzer, and for coding purpose we use Python and SQL. So yeah. So this is the basic block diagram of the project that if a person is entering a premises, the using camera we analyze the person and then it reprocesses the face and then detects the face by comparing with it with the database, and if the person is recognized and then only the entry is granted for that particular person. So this is the flow chart. Yeah, so this is the flow chart regarding how the exactly it works. So it the image is stored in the database previously for the persons who are in the hostel security system. Then the camera captures the photo for each and every individual entering the premises. If the uh, that person's image is compared in the database and it is authorized or it is already present in the database, then only the entry is allowed in the campus. And then if it is not, then the a warning message or message is sent to administrator that if this is a new person, you want to allow him into the premises, or if there are some other persons also for any other work related to maybe cleaning or some vending or whatever. So if you want to authorize them, then the administrator can allow that person and then they can enter. Then if they are denied, it is denied. And for students we have also sorry so we have also added that if a student is entering late into the premises, even though he is known but he has exceeded the time limit, then a message is sent to their parent and the administration also. Yeah. So yeah, this is the working. We have divided our working into 5 different modules. First is face detection. A 3D face detection algorithm is used. It will detect each person's face entering in the campus, and it will check in the database if it is already present or it is known to the system or not. Then it reprocess. The second is reprocessing. It reprocess is used using arcade algorithms, and then it reprocess the face if it is covered or it is something is hampered with the image, then it reprocess according to its knowledge. And then yeah, for training and recognition, face recognition is also used. So faces means if there a person is entering the premises or someone is trying to um, false entry or using photograph or phone ID, that is also covered with this project, that we are trained faces and the recognition system made it so strong that it cannot be hampered with the other other kind of activities like showing photograph and all that. So last one is database management. So we have kept all the entries and all the person's images into the database so that latest images is also every time is refreshed by the system. So our project accuracy rate is high. So the recognition library used in the system can accurately determine whether the person is trying to gain access to the campus matches the database of people who have been authorized to enter. Automation of this project is like once the setup is done, only access granted people are allowed into the campus. So it will automatically detect a match. And so manual observation or manual work is not needed every time. Once the setup is done, it is fully automated. Yeah, the processing is also very fast. So within 2-3 seconds we can get the results of whether the person is known or unknown. Yeah, so these are the results. So for the this project purpose only, I have added my name and my entry. So if I am a known person to the system, and time is also within the time limit because I have added my name as a student. So yeah, so this is the known person, so entry is added. So for late entry, so this is the late entry. We have exceeded, the person is exceeded his time limit for entering the hostel campus. So the entry is shown, but also a message sent to the parent. So we can see this screenshot of message that your ward is entered late at the premises. Please contact the warden regarding this. So the same message is sent to warden also. So yeah, for the unknown person, this is my entry. My image is added into the system, and it asks whether you want to add it into system, or do you want to just uh, whatever do authenticate the person. So yeah, the message is going to the sent to the administrator. So after upon his action, the next set of action is take. So this is a quick review or recap of how the system works. For known persons, there is a time limit for entry allowed with late entry, and then parents is informed. And then if unknown person is trying to enter, administration gets the notification. All this. So advantages of this system is like it is automated. Once the setup is done, we just need to monitoring, and time to time just need to update the photographs in the database for the latest or for more accuracy. And then it is cost effective. It's as it is one time investment only. In security is increased by this, because not even if just considering hostel, we just get all the peoples residing in the campus, they are just secured. And it is time saving also. And yeah, management are also easy with this system. So for this applications, uh, if we expand our system to the mentioned areas like school management, hostel staff attendance, office security, jail management, ICU. So upon the different locations also, we can install this system, and accordingly, by changing just a small database entries and small changes, we can just expand the coverage also. So conclusion is this: as face is a very important identity of human being, the proposed system uses camera to capture images for training and testing. It reduces memory consumption as well. So along with face identity, alert message is an advantage of this system. The system can work with a literal environment change and pose variations. So the system performance can be improved by integrating more facial features and by applying algorithms. Better camera resolution will further increase more performance of the system. Yeah. So for the future scope, this system that will generate the payroll of all the employees of this hostel. All accounting details can be maintained. In addition, if we just means we are trying to expand this project, as it is just security system, we'll just change the database entries for different people, and different categories can be also made, and by that, yeah, we can expand the scope. Yes, I just want to thank you for having me. So any further questions or any suggestions? uh,
Okay, so you have implemented the hardware for real-time recognition and login.
Yes, initially we tried using Raspberry Pi and the hardware, but we didn't get it very working conditions. So we tried it using a camera that is installed on laptop. So for the
Okay.
records or the results are shown are using the laptop camera, not with the hardware.
Okay. And you have ensured any data privacy or security?
As of now, we are just using MySQL, so data privacy is not means that much.
But if you are looking for the hostel management, real
Yeah.
world hostel management system,
Mhm.
then you have to consider that parameter into consideration.
Yes, sure. We are just again implementing it with more accuracy, and more suggestions are also we are getting more suggestions also. So we'll took this also, and yeah. Thank you.
Okay. Okay, thank you.
Thank you so much for your presentation. With this, we come to the end of our session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the other previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certification through email within the 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I would also like to thank our session chair, Dr. Aneri Pandya, for chairing our session, ma'am. Thank you so much for being a part of our session today. Any final thoughts before we conclude our session?
Yes, first of all, I will thank all the presenters for sharing their impactful research. And it has been pleasure for me as an session coordinator for ICT4SD. And I am thanking whole team of ICT4SD for this opportunity. Thank you.
Thank you so much, ma'am. With this, we come to the end. I just request all of you all to please switch on to your cameras for a quick snapshot of this virtual conference we just attended. Thank you so much. Take care, stay safe. We'll meet you in 2026 with our next conference. Thank you.